So basically in this section we're taking the converse of all of the theorems from the last video. So we'll be discussing in this video how to identify if a quadrilateral is a parallelogram, given some information about it, and then we're going to use those theorems to find certain values using algebra. So, what are the conditions for parallelograms? These are theorems. Now there are 4 theorems for conditions for parallelograms, but I added one more statement. The first statement is not a theorem, but it holds true. So the first statement says if both pairs of opposite sides of a quadrilateral are parallel, then it's a parallelogram. So if I just have a quadrilateral and I know that the opposite sides, both pairs of opposite sides, are parallel to each other, then I can say it's a parallelogram. The second, third, fourth, and fifth are theorems. So it says if the second one says if both pairs of opposite sides of a quadrilateral are congruent, then it's a parallelogram. So if I have a quadrilateral and I know opposite sides of the quadrilateral are congruent, I know it's a parallelogram. The second theorem says if both pairs of opposite angles of a quadrilateral are congruent, then it's a parallelogram. So if I have a quadrilateral, I know its opposite sides are both congruent to each other, then it's a parallelogram. The third theorem says if the diagonals of a quadrilateral bisect each other, then it's a parallelogram. So if I just have a quadrilateral and I know that the diagonals bisect each other, I know it's a parallelogram. And the last theorem says if one pair of opposite sides of a quadrilateral is both parallel and congruent, then it's a parallelogram. So say I have a quadrilateral and I just know that this side is congruent to this side and it's also parallel to this side, then I can say it's a parallelogram. I don't need to know anything about the other sides. So let's use these theorems and these conditions for parallelograms. Okay, so on this slide I have 2 quadrilaterals. I want to know, are these quadrilaterals parallelograms, using the conditions for parallelograms theorems. Well, in this first quadrilateral, I know that both pairs of opposite sides are congruent. So 35 and 35 are congruent, 20 and 20 are congruent. Well, that means using the theorem that says if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. I know that this guy is a parallelogram. Then when I look at this one, well, let's see, I know opposite angles are congruent, and I know that one pair of opposite sides are congruent. That does not meet a condition for a parallelogram. I have one theorem that says that both pairs of opposite angles need to be congruent. Well, I only know that one pair is congruent. And then I have another theorem that says both pairs of opposite sides has to be congruent, but I only know that one pair of opposite sides is congruent. So this one I cannot conclude that it's a parallelogram. I'm going to say it's not a parallelogram. So I can't do every possibility of using algebra to determine if a quadrilateral is a parallelogram. There would just be too many combinations. We'd be dealing with opposite sides, we'd be dealing with opposite angles, we'd be dealing with diagonals bisecting each other. So I'm just going to do one problem, I'm going to just do one problem that involves sides, but I want you to know that there's many ways that we can use these conditions of parallelograms to determine if a quadrilateral is a parallelogram. Anyway, so you might have a problem like this that says, it'll give you a parallelogram, it'll say find x and y so that the quadrilateral is a parallelogram. And so if I wanted this quadrilateral to be a parallelogram, then its opposite sides would have to be congruent. So these two sides are opposite sides. So 3 times y plus 1 would have to equal 4y minus 2. And then I could just do some simple algebra here, distribute the 3. I get 3y plus 3 equals 4y minus 2. I could subtract the 3y, so I'd have y on this side, and add 2, so I'd have 5. So y equals 5. I have my y. And not only do these two sides have to be congruent, but these two sides have to be congruent if it was a parallelogram. So I would just say 4x minus 1 equals 3 times x plus 2, and do some algebra, distribute the 3. So I'd have 4x minus 1 equals 3x plus 6. Subtract the 3x, I'd be left with x on the left side. Add 1, I'd be left with 7 on the other side. So I just solved for x and y to make this quadrilateral a parallelogram. Okay, that's it for this section. Good luck on the practice problems, and of course, let me know if you have any questions.